Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 5 in our new, our improved, our exciting tutorial series on the Arduino microcontroller. I need you guys to go ahead and pour yourself a nice mug of iced coffee. I need you to get your Arduino out, and we are going to learn a very important lesson today. And what we're going to learn about is we are going to learn about working with binary numbers. And this is one of the most important lessons that we're going to do because kind of the theme of this new series of Arduino lessons is I really want you to understand with an Arduino what's going on underneath the hood. I don't want you to just think about this little board that I can send commands to and it does what I want. Like I can send it a series of commands and then it does what I want it to do. I want you to start understanding how it does what it does. And we started that really in lesson 2 where I started explaining to you how an LED works. There's a lot of physics going on with an LED, and we started talking a little bit about solid state physics, and we started talking about semiconductors. And one of the things we learned about semiconductors is that all digital devices, from Arduinos to digital cameras to cell phones, they're all made of semiconductor devices, and a lot of these are made out of silicon. Okay, and what we learned about a semiconductor device is a semiconductor can be a conductor or it can be an insulator. And you can switch it from being a conductor to an insulator by applying a voltage to it. So you could see that the LED, if you don't apply a voltage, it's off. If you apply a voltage, you cause it to become a conductor and it turns on. So you can turn an LED on or off. You can have it in a conducting or you can have it in a non-conducting state. That is kind of at the heart of how digital devices work. Digital devices operate based on tiny switches. The switch can be on, conducting, or it can be off, insulating. And you can apply a signal to the switch to flip it either on or off. And the way to think about it is if the switch is on, think of it as a 1. If the switch is off, think of it as a 0. So LED on, that's a 1. LED off, that's a 0. And this is the way to think about things. Again, I'm trying to get you from, you've got the real world as you're walking around and you're interacting with all of these physical objects, and how do you map that onto something like a computer or an Arduino? So the first thing that you have to see is anything around you, whether it's colors or music or numbers or letters or words or pages, they can all be represented by a number. Okay, so first of all, numbers can be represented by numbers, right? I got 3 fingers up. Okay, 3, that's a number. Numbers can be represented by numbers. How about letters? Letters can be represented by numbers. You could say an A is a 0, a B is a 1, a C is a 2, a D is a 3. So I could represent any letters by numbers. So if I can represent letters by numbers, I can represent books, I can represent words by numbers. And if I can represent words by numbers, I could represent a whole book by a number. So I could take a book and I could change it into a number. Same thing with colors. You can change colors into numbers. Same thing with music. You can change music into a series of numbers. So almost anything you interact with in the real world, you can represent as a number. And that's kind of how computers work. You take all of these things around you, and the only thing that a computer or an Arduino or a digital device understands is numbers. Everything is converted into numbers. Now, the thing about a digital device like an Arduino or like a computer is they're kind of stupid. They only understand 2 numbers, a 0 or a 1, right? They're a bunch of little switches, and those switches are either off or on. They're a 0 or a 1. Well, you can't do much if you just have one switch, like one diode, one switch. You could only do 2 things, off, or on. So how would you do something more complicated like music or a page of text? Well, you need more than one switch. The good news is on these digital devices, the switches are tiny. The switches are tiny. And so on something like a microcontroller chip, you can have 1 billion with a B, or you can have 10 billion switches. Each switch only knows whether it's on or off, a 0 or a 1, but you can have many, many, many switches together, and so you take something very simple like the concept of on or off, 0 or 1, and all of a sudden you can do magnificent things like having digital cameras or iPhones or music players and all of that stuff, but it all comes down to zeros and ones, because anything in the real world can be represented as a number, and any number can be represented by a series of zeros and ones. And a series of zeros and ones, what this is known as is it's known as binary. Okay, binary numbers. So if you're going to understand the Arduino, if you're going to understand how computers work, what you have to do is you have to understand binary numbers. Now, you know how I like to teach. I like to teach by taking you back to something that you understand. What is it that you understand? You understand how to count. And so I want to take you to your world of how you count, and then understanding what you're really doing, I'm then going to show you how binary numbers work. So when you count, what is the first number? No, it's not 1. The first number is 0. Okay, so if you're going to count, you're going to start with 0, and then the next number you add 1 and you get a 1, and then you add 1 and you get a 2 and a 3 and a 4 and a 5 and a 6 and a 7 and an 8 and a 9. Stop! Stop. Don't go on, because it's just going to roll off your tongue, but I don't want it to roll off your tongue. I want you to understand what you're doing with the next number. And if you understand what you're doing, then you'll be able to understand how binary numbers work, okay? So what is the problem? We start with 0 and we go to 9. We have 10 different characters, and you've just used up all 10 characters, but you need another number. So what are you going to do? Are you going to come in and make another character, and then the squiggly, and then the wavy, and then the this, and just come up with a new character for every number? No, because you won't be able to remember all those. You can kind of remember 10 characters, which are 0 through 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you understand how you have 10 characters? And starting with 0, you counted to 9. You've used up all of your characters, but you want to add one more without coming up with a new symbol. So what do? 9 plus 1 is 0. Carry the 1. So what you have to see is 10 is 9 plus 1. 9 plus 1 is 0, and you carry the 1. And now you start cycling again. Now you can use this one again. You can add 1, and the 0 becomes 1, and you still have this 1 here. So what I want you to see is what you are doing. You are adding 1. You run out of characters. 9 plus 1 is 0. Carry the 1. All right. Well, if we are going to, instead of having 10 characters, 0 through 9, no, you only have 2 characters. You're going to use them up pretty quickly because you only have a 0 and a 1. But the exact same concept is going to hold up here. I think I should zoom in a little bit here so you can see. Okay. Let me come a little bit more because I really want you to see this clearly. So what we're going to do is, instead of having, like if you look here, we have 2 digits that we played with. Here we are going to have 4 digits. So we're going to have this, 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 and this. We're going to have 4 digits here that we are going to work with. 4 digits. And since it's binary, you're going to think of these as 4 switches. So where are you going to start with your switches? You're going to start off, 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 off. That's 0, 0, 0, 0. What number is that? It's 0. Okay, it's 0. Now you have 0, 0, 0, 0. You want to add 1 to it. So you do this at this least significant digit, and you add a 1. 0 plus 1 is 1, and then the rest of these remain 0. And so if you think back about switches, this instead of off, 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 this is on, off, off, off. And this is the number 1. Okay, now we're going to add another 1. 1 plus 1 is, no, it's not 2. What did we do here? 9 plus 1 is 0. You got to go all the way back to the top, and you've got to carry the 1. So 1 plus 1 is what? It is 0. Carry the 1, and then the rest of these are 0. All right. Now I'm going to add another 1. Well, 0 and 1 become 1. You still have this 1. You have 0 and 0. Now this is where it gets a little harder. So I'm just going to zoom in on this one problem, right? We had, where did we end up? 0, 0, 1, 1. And now we want to add 1 to that. Okay, we have 0, 0, 1, 1, and we want to add 1 to that. Well, how do we do that? 1 plus 1 is, no, 1 plus 1 is not 2. 1 plus 1 is what? It's 0, carry the 1. Now I have 1 plus 1 is 0, carry the 1. And now 1 plus 1 is 1, all right? And then 0 comes down. So when you have 0, 1, 1, the next one is going to be 0, 1, 0, 0. So the next one is 0, 1, 0, 1. I mean 0, 1, 0, 0, right? 0, 1, 0, 0. All right. Now it gets easy. We add 1 to the 0. It's 1, 0, 1, 0. That was easy, right? Now we add 1. 1 plus 1 is 0. Carry the 1, and then 1 and 0. It's still pretty easy. We add 1, and so this becomes a 1. We still have this 1. We still have this 1, and then this is 0. Here's where you've got to be careful. So let's do this. We have 0, 1, 1, 1, and we're going to add 1 to it. 1 plus 1 is 0. Carry the 1. All right. 1 plus 1 is 0. Carry the 1. 1 plus 1 is 0. Carry the 1. And so now we have 1, 0, 0, 0. So this becomes 1, 0, 0, 0. Now it's going to get easy again. If we add another 1, it's going to be 1, 0, 0, 1. We add a 1. 1 plus 1 is 0. Carry the 1. And then I've got 0 and 1. And now add a 1. It's going to be 1, 0, 1, 1. Okay, let's keep going. Let's say we go 12, 13, 14, 15. Okay, now if I add 1, 1 plus 1 is 0, carry the 1, and then I've got a 1 and a 1 is 0, carry the 1. I bring this 1 down. Okay, now I add 1, it's going to be easy, 1, 1, 0, 1. Now, 1, 1, that 1 and 1 is 0, carry the 1, and now I add 1, and I've got 1, 1, 1, 1. Ooh, you kind of lost where you couldn't see that. All right, so then it's 1, 1, 1, 1. Now, what if I added 1? Well, it's going to be 0, 0, 0, 0, and carry the 1. I've run out of digits. I can't add another number. I can't go to 16 with just 4 switches, with just 4 bits. So we'll just leave it here at 15. If I wanted to go to 16, what it would be is it would be 0, 0, 0, 0, and carry the 1. I would have to have another switch out here. Okay, but we're just going to do the 4 switches. What you have to see is I was counting by what's here, by ones. I was counting by what's here, by ones. And so the decimal number 0 is the binary number 0000. The decimal number 1 is 0001. The number 2 is 0010. Okay, these are the same numbers. 15 is 1111. And so if you start looking here, you see a pattern, right? There's a pattern, 0, 1, 0, 1, 0, 1, 0, 1, because you're adding 1. And then you go 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. Then you go 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. And then 8 zeros and then 8 ones. So you see, there's a pattern of how these binary numbers work. But this is a way, like let's say if I just give you a binary number and then I want you to go from binary, so this is decimal, this is binary, and now let's go back to decimal. So this is what I want you to see. How would you figure out that this binary number is the decimal number 8? Well, what you have to see is just like this is a number times 1 plus a number times 10, you can see this digit is worth 10 times the number. This digit is worth 1 times the number. Well, it's the same thing, only a little different. This column is worth 1 times the number, so every time you have a 1, it's worth 1. This one is worth 2 times the number. This one is worth 4 times the number. This one is worth 8 times the number, 16, 32, 64 if you went on. So let's see. 0, 0, 0, 0 is the decimal number 0 because there's not a 1, there's not a 2, there's not a 4, there's not an 8. The number 1 is the number 1 because this place is worth what? 1. All right. How about 0, 0, 1, 0? Well, this 1 is worth how much? 2. You starting to see it? How about let's do this one? Okay. This is worth 1. This is worth 8. 8 and 1 is 9, which you have there. How about 15? Well, that's an 8 plus a 4 plus a 2 plus a 1. That's 15. And do you see that with just 4 switches, we've been able to represent 16 different numbers. 0 to 15 is 16 different numbers. If we had 5 switches, we could represent 32 numbers. If we had 6 switches, we could represent 64 numbers. So just by stacking a certain number of switches together, we can really quickly represent incredibly huge numbers. So if you said 1,234,321, you would just need more switches, and then you could go in and use this process, and you could turn any number into a series of zeros and ones. If you can turn any number into a series of zeros and ones, then you can deal with it with something like an Arduino or any digital device because you're turning a number into zeros and ones, which then at the hardware working level on the Arduino or the computer or whatever, is going to be switches that are on or off. And so like we have off, 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 off. We have on, off, off, off. We have on, off, on. So you see switches like the diode. Remember how we turn the diode on and off? Remember in solid state physics in lesson 2, we were switching the diode from conducting to non-conducting, on, off, 0, 1. So this is how a computer works. Any color, any music, any letter, any book, any number can be represented by a number, and any decimal number can be represented by a binary number, and any binary number can be realized with something really simple, a series of on and off switches. And that is what happens on the silicon. It is a bunch of on and off switches. There is only one thing on a digital device, and that is a switch. And then there are many, 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 many copies of that switch. But digital computers, devices, are nothing but humongous numbers of switches. So like a modern microprocessor would have billions and billions of switches. But that's all it is, billions and billions of switches connected together cleverly so that it can represent anything as a series of zeros and ones. Okay, guys, this is your assignment for next week. What I want you to do is I want you to make a digital counter using your Arduino. Remember your most excellent eLego Super Arduino kit? You have LEDs in it. And I want you to make an LED counter that will count from 0 to 15. Now, how would that work? Well, how many LEDs will you need? You will need 4. All right. So how many pins will you have to connect those LEDs to on the Arduino? You'll have to connect to 4 pins. How many resistors will you need for this circuit? You will need 4 because each LED will need its own current limiting resistor. In your program, how many pin modes will you need? You'll need 4. Be sure and use variables because you are going to have 4 LEDs. You'll have 4 pins you're using. You'll have to do 4 pin modes. Then what would you do? Well, I'll give you kind of a little hint. You'll do digital write, and then you'll use your pin, whatever your pin is, your first pin, and then you will write it low, right? You'll write the first one low, the second one low, the third one low, the fourth one low, and then you'll do that. Then you need to put a delay in because if you don't, you won't be able to see it. So you'll need to write all of these low, and then you will need to have a delay. Then what you'll need to do is write the LEDs low, 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 high, and then put a delay, right? And then you will need to write them low, low, high, low, and then put a delay. And so what I want you to do is I want you to make a counter where it will be off, 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 wait a second, and then off, 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 on, and then wait a second, and then off, off, on, off, right? Like that. Off, off, on, off. So really, we could look at it like off, 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 what? On, off, off, on, off, 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 on. I want you to cycle through these. Put the LEDs like this, wait a second. Then put them like this, wait a second. Then put them like this, wait a second. Then put them like this, wait a second. And then cycle all the way down through all 15 numbers. And then if you do that in the void loop, it will just start over again. Okay, guys, this is really exciting stuff to me because, you know, even though I'm trying to do this quickly, it's really the essence of how an Arduino and every other digital electronic devices work. Everything is just a bunch of zeros and ones, and that's a bunch of switches that are on and off. And you are going to do this first binary assignment by writing the code and building the circuit to make a binary counter with the Arduino. Okay, guys, if you like this video, think about giving us a thumbs up. Think about subscribing to this channel, maybe sharing with other people. This is Paul McWhorter from TopTechBoy.com. I will talk to you guys later.